So there's another kind of kinematic motion that we need to consider, that of objects moving in circles. So in 1D, if your velocity equals 0, then you know that the acceleration is also equal to 0, because your acceleration is defined as a change in velocity. So if the velocity isn't changing, its acceleration has to be 0. But in 2D or in 3D, if v equals 0, your acceleration doesn't necessarily have to be equal to 0 as well. How is that possible? What? So we know acceleration is equal to dv over dt, the change in velocity over the change in time. If v isn't changing, if v equals 0, then it can't be changing. How can you have acceleration not equal to 0? It's all about this little arrow right here, this guy. That means that we are working with a vector. Vectors have magnitude and direction, and the direction can be changing. So even if the velocity is equal to 0, if the direction of that velocity changes, then it has some acceleration. Okay. And objects moving in circles, they are constantly changing direction. Right? If I have an object that's moving in a circle, looks something like this, then at this point, the velocity, I can be going up, and there's my velocity. But then as I'm going up, as I'm traveling along this circle, I'm moving. So my velocity is constantly changing direction. At this point, my velocity is going off in this direction. As I keep going around my circle, up at the top of the circle, my velocity is now pointing entirely to the left-hand side. So the direction of velocity changes when we're traveling in a circle, and we call this centripetal acceleration. Turns out that every object that's moving in a circle experiences a centripetal acceleration, and that centripetal acceleration always acts towards the center of the circle. So at this point, on the right-hand side of the circle, my centripetal acceleration is pointing to the left. At this other point, when I'm up at the top, the direction of the centripetal acceleration is changed. It's actually pointing down. So direction of centripetal acceleration always points towards the center of the circle. And if I want to know the magnitude of the centripetal acceleration, I can calculate that. That's going to be equal to v squared divided by r. And it's always going to be towards the center of the circle. We're going to want to keep these things in mind as we keep exploring circular motion in later chapters.